To find the zeros of this function, we could use the rational zeros theorem and Descartes' rule of signs and start testing some things. But actually, the first thing you always want to look for is see if you can factor it. You may overlook that step when you get into the habit of using those other theorems. But here, if we look at this, we can factor this by grouping. And if you can't just see that right away, that's totally fine. You can always just try it and see if it works. So if we group this into our pairs, x cubed plus 3x squared, we can factor an x squared out of that. So x squared times x plus 3. And then negative 16x minus 48, we can factor a negative 16 out of that, and we are left with x plus 3. So this is super nice. We've got an x plus 3 in both of these, and so we can factor the x plus 3 out. And that leaves us with an x squared minus 16. And then x squared minus 16, that's the difference of squares. And so we can factor that. And we get x minus 4 times x plus 4. And so now to find our zeros, we just set each of these factors equal to 0. And so if we set x plus 3 equal to 0, we get x equals negative 3. And if we set x minus 4 equal to 0, we get x equals positive 4. And setting x plus 4 equal to 0, we get x equals negative 4. And those are our zeros for this polynomial.